Welcome to another episode of Software Explorations with Tech Coach Ralph, where we are always and forever engineered to win. In today's episode, we are going to talk about functional testing, understanding all the ins and outs about it, and its difference to non-functional testing. So, if we are all ready, let's get into it. So, what is functional testing? Well, I think the name says it all. It's testing the functionality of an application that we are building. So, let's get into the presentation and we'll break it down even more. So, our topic for today, as I've already stated, is understanding functional testing. So, what is the definition of functional? The definition is of or having a special activity, purpose, or task relating to the way in which something works or operates. So that's what the word functional means, pretty much how something works or how it operates. So let's get into our agenda for today. We're going to be talking about what is functional testing compared to what is non-functional testing. There is a big difference, and I think a lot of times people overlook what non-functional testing is. So we're not going to get too much into non-functional testing today, but we are going to differentiate the two just so you can already have an overview and an understanding. And then next week we can possibly get into non-functional testing. Then we're going to get into the types of functional testing. We're going to explore each type. We're going to talk about the functional testing strategies, the functional testing process, and we'll finish off with the functional testing best practices. Now, let's talk about functional testing. The focus of functional testing is what's the focus of functional testing? It's concerned with testing the software's functionality against the specified requirements. It ensures that the software behaves as expected and performs the intended functions. So pretty much the way that the application that you're building, the way that it's defined to work, functional testing is going to verify that. So if you're supposed to go to steps A, B, and C, functional testing is going to make sure that steps A, B, and C works as expected. The primary goal of functional testing is to verify that the software meets the functional requirements and works correctly from the user's perspective. So the user's perspective is also a key point, right? Because although it can meet the requirements, but if it doesn't work properly for a user, then the software is going to be useless. So all of that comes into consideration when we're talking about functional testing. It's not only that the acceptance criteria is met, but we also have to take it in the mindset of a user, how they're going to use it. And we write our testing strategy based on how the user is going to use it. Our acceptance criteria should be based on how the user is going to use it. We can probably get more into the acceptance criteria and user stories when at a later date. But the functional testing is the key component to verifying our acceptance criteria and our requirements. So functional testing, what are some examples of functional testing? We have unit testing, we have integration testing, we have systems testing, we have user acceptance testing. So those are all examples. I'm going to throw in there regression testing as well and retesting as well. All right. And then we have our test cases are part of functional testing. Functional testing involves creating test cases based on the software's functional specifications, the user stories, and the use cases. So we already went through a presentation talking about test cases, but test cases are a part of functional testing where it provides written steps on what the user or what the tester, and just about anybody can follow the test cases as well, but what they need to follow, the steps they need to follow to test the functionality of the website based on the user stories and especially the acceptance criteria in the user stories. Now, the types of functional testing. It's further divided down into black box testing, white box testing, gray box testing, and there's more too, but those are like the main ones. And I think gray box testing is fairly recent, but mostly it's been black box testing and white box testing. What about non-functional testing? What's that? So the focus of non-functional testing is that it's concerned with testing attributes of the software that are not related to its specific functionality. Instead, it assesses aspects like performance, security, usability, and more. The purpose of non-functional testing is to ensure that the software meets quality attributes beyond just its functionality, thereby enhancing the overall user experience. So, an example of that is you can have the software working like perfectly fine, just as you expected, but because you don't have the right amount of servers configured for it, the software takes forever to load. So, although the functionality works correctly, but the application is not actually functional because the configuration is not proper, and so it has performance issues. The same way is you can have the functionality of the application working 100% accurately, right? However, it's not a secure application, and like let's say it allows you to like it doesn't require a username and password for sensitive data. So it's although the application is functional, it passes its functional test. It's still like it's not working because if there are security risks, then nobody's going to use your software. All right. So I hope that gives a good understanding about what the non-functional testing is. And to continue with non-functional testing, so some examples of non-functional testing is performance testing, security testing, usability, compatibility, load testing. Those are all examples of non-functional testing. And we'll get more into that in another presentation because today we are focused on functional testing. So how about test cases for non-functional testing? So they involve creating test cases that assess specific non-functional attributes of the software, such as the response time, security vulnerabilities, etc. So a quick example of that is if you're doing a load test, right? And the test case would say, given given this amount of traffic being sent to the application, this is the expected results, right? Or security vulnerabilities. If you try to access the server of this application, or you try to do any particular dangerous 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 thing, right, on the application, this is what you should get, or it should block that IP, something to that extent, right? And the types of non-functional testing, they're categorized into different types based on the specific quality attribute being tested. All right, and we'll break that down more in a later date when we talk more about non-functional testing. So, what are the key differences between functional testing and non-functional testing? So, the focus of functional testing checks whether the software's function works as expected, while non-functional testing evaluates aspects like performance, security, and user experience. So, we mentioned that earlier, but we just want to put them side by side. Now, the requirements for functional testing is based on functional requirements, while non-functional testing is based on, you guessed it right, non-functional requirements. So, and that makes perfect sense because there's no functionality that you're actually following when you're doing a load test or a security test. You still have test cases for them, but it's not a step-by-step guide. It's more like analyzing data in a lot of those non-functional tests. Additional key differences are the user perspective. Functional test ensures that the software meets user requirements, where while non-functional testing ensures that software meets user expectations. So, do you see the difference between the user requirements and the user expectations. So the requirements are when I go through these set of steps, then I should get this particular end result. However, the user expectations is when I go to this, like when 10 people go to the site, it should still load within less than a second, right? Things like that. The scope of functional testing is concerned with what the software does, while non-functional testing is concerned with how well the software performs those functions. So functional testing, how well, like how accurate the like there's no bugs in the software and things like that. But non-functional testing is, although there's no bugs, does the site load in this amount of time? Are there security vulnerabilities? All of that type of stuff. So it's also having the right design. They're just two, like they're they're both like just as important as each other, because if the site is working, but or if the site is functional, right? Like let's say you're doing a website and you can actually create an account, but it just takes forever for each page to load. The site is not working properly, although your functionality is working, your performance is terrible, and you're going to lose customers either way. They're not going to be able to make any transactions on your website. So a quick example: when the ACA website came out, whenever it was released back then, and so it was launched, and then it couldn't handle the load. So the functionality of the website was like most likely working as expected. However, it couldn't handle the load, and people were not able to sign up for their healthcare insurance, right? So so the part where the site is crashing all the time, I mean, it could be part of functional testing if, for instance, it's a React error, and when you click on something or you enter something in, it gives you a blank page. But but most likely it wasn't able to handle the load of the amount of users who are going to sign up for it. So yeah, so that's like, so that gives a good breakdown and the difference of functional testing compared to non-functional testing. So what are some functional testing strategies? So as mentioned earlier, there's black box testing, which you're testing without the internal knowledge of the code. There's white box testing where you have the internal knowledge of the code. And there's gray box testing that's combining the white box and the black box testing to give you gray box testing. So let's talk about black box testing for a little bit. With when it says without internal knowledge of the code, right? So most QA engineers, they're going to be working in the black box testing part of it, right? Even if they're able to see the code for the most part, most QA engineers, they're not software engineers to be able to understand all the ins and outs of what the code is doing. And if they were, they wouldn't have enough time to get anything else done, right? So they're testing without knowing all the back end structures of how the code is built. Because at the end of the day, it shouldn't matter that much to a QA engineer. What matters the most is that the application is functional, and that what you're able to use, whether it's APIs or that it is a GUI interface, whatever it may be, right? That it is functional. So what you input in is going to give you the right output. We're not too concerned about what goes on in the background. The code could be a mess for all we know, right? But what's presented to us is a functioning software. Now, with white box testing, that is testing with the knowledge of the internal code, and that is what the developers do most often, right? They'll write unit tests. So unit tests would be a part of white box testing in my opinion, right? Because their unit test is validating that their code, their internal code, is working properly. So what does that mean, right? So in programming, there are functions, or like some languages call them functions, some languages call them methods. They ultimately do the same thing, right? But let's say you have I'll call it method because I've been doing Java for forever, and that's just the terminology that I'm familiar with. But if you're a Python person and you write a function, that's perfect. Like they're almost the same thing. It just depends on the language, right? But not to get off track, if you write a function, right, or a method, and it's an addition, it's an addition method, right, and you put um it takes two variables, right, let's say a and b, and it does. So now when you're executing it, you pass like 5 and you pass 10, right? So from a black box perspective, we don't know what's going on in the background, right? So all we know is when we enter 5 and 10, we should get 15, right? Um and if we enter like some other like special characters or something, we should get like an error message, right? And we're just like validating the error. But from the white box perspective, when the developers are writing their unit tests, they know how they built the code, so they know how to like they're coming up with a bunch of various unit tests to check their inputs and stuff like that. So and as part of the testing pyramid, the most amount of tests should start with the unit test, right? Because that is like the closer you are to the code, the more tests that you want to have. And then as you get further away from the code, the amount of tests reduce. And one of the reasons for that is the closer you are to the code, to the internal code, your tests have the ability to run a lot faster because you are like it's not because of your proximity, like a physical proximity. It's because the level of detail that you're able to have with what the code is doing, right? So to break down the testing pyramid real quick, we'll have like on the very bottom layer, the most tests that we should have should be our unit test, right? Because it's testing with the internal knowledge of the code, right? Then we go on to like our component and integration test, where as that gets further away from the code, then there starts to be less of those tests because there's the way that things are being integrated with one another. It's just not that many connections that's being made because most of the implementation is happening in the internal part of the code. And as you get to integration, you start getting further away from the internal part of the code, right? So, and when we get to like, and all of that, right? It should be testing the business logic, right? The closer you are to the code, the most tests that you have, that should be testing your business logic, right? Um, what the purpose of the story and everything like that. Now, the very like the top part of the testing pyramid, which I guess that could be like some manual testing, or but it would include like the UI tests, right? Where those tests are generally more flaky. They may like they're subjected to timing issues and stuff like that. So so you want to have the least amount of those tests to just it's like more of an end-to-end spot check type thing. You don't want to like have to test every single component because the developers should be writing adequate unit tests to cover most of that. And then once it gets to like integration, API, business logic type stuff, those should be done like usually like on an API type layer, right? And then the last step would be like just spot checking some GUI things to make sure that that's working as expected, right? And then like with gray box testing, I would say that's probably a software development engineer in test, right? In SDET, or like a senior QA engineer who has understanding of the code, which they can even contribute to some of the code, like but very minimal, like making a small change here and there. And then they're like building tools to test. So they dabble in between the black box testing and the white box testing. So and even I've like made some minor changes per the request of the developers while I'm working on my automation code because I'm already in the branch, right? So I hope that makes sense. If you have some more questions about it, feel free to leave me a comment, send me an email, whatever the case may be, and I'll be glad to break it down a little bit more. And maybe one day we'll break these videos down even more. All right, or not videos. We'll break these functional testing strategies down even more, so you can see how you use what testing strategy. Um, when you're testing your application. But what is the functional testing process, right? And we kind of went over this the past few weeks. So we have the test planning, which we already spoke about, to planning your tests. We have our test case design, which we went over that as well. And on the live stream, we created a test case. All right, we have execution, where we have a video for that. We have the live stream where we were executing tests, right? And then we have defect reporting and tracking, how to report a defect and how to track that defect, or whether you're putting it in a test case management system, whether you're using Jira, whether you're using Excel. So those the functional testing process, what you would have to go through. Now, what are some best practices for functional testing? Well, probably the most important one is going to be testing early and continuous integration. Um, Testing early allows you to, which that is one of the best parts about Agile when it comes to testing, is that you have the ability to develop, like you're so close to the code yourself as a QA engineer. So as the developers are developing and releasing to the branch, you can start looking at the code, not even necessarily the code per se, but you can start trying to install it and run some tests to see how things are working, and then continuous integration as well. So one way that we do it is that when we run our tests, our automated suite of tests on the branch that that the development work is done on, and then it also runs it, like once a merge is done, it runs it on the master branch as well, right? So continuous integration is a critical part, and something that I try to do as well. Even before the development is done, I try to prepare my test cases. So I try to prepare my automation tests. So when the development is done, I just have a few minor updates, and then I can run the automation tests. So I'm running the regression test, and I'm also running the test for the new implementation, to make sure that that is working. So I'm doing some manual tests, I'm doing some automated tests, but while the developers are working, I'm trying to start preparing the automation work that I'm going to do. All right. And there's traceability between. So the next point, there's traceability between the requirements and the test cases. So just being able to easily link them to one another, know what test cases belong to which requirements. So it's a quick reference guide. And like when the test execution happens, and then it updates the test case, which updates the requirements to let you know what's going on. All right. And then we also want to have a robust test suite, or robust regression test suite, right? And the regression is going to be, for 99% of the time, it should be automated. Can't really think of a reason that it wouldn't be automated, but you'd have like, whenever there is a release that happens, you execute the regression test, and you get the results for that. So if the regression tests fail, now you have to hold the horses and see, okay, what failed, and because usually unless like specified, the functionality should not be breaking when development is being done, right? And it's explicitly stated. And then you also have to make sure you update the users. And if you have a mass amount of customers, you have to update them that things are going to be working differently, right? So we want to test everything that is already existing to make sure that the new implementation did not break our existing functionality, right? So that's number one. Because if it does break, if it changes the functionality of something that's existing, then that should also be part of the acceptance criteria, saying making this change is going to be affecting this part of the website, right? Or this part of the application. So that's why whenever we have we create a new branch and we push to that branch, we're going to run our regression suites against that branch, and then once we merge it into master, then we run the test against master 2, all right? Or master as well. And then the last part is exploratory testing, which after you do all of the above, then you can start like playing with the with the application. I always say website because I've been working on websites for so long, but with the application, right, you can start playing with it, seeing different things that are happening, and you're not following a defined set of test steps. You're just like exploring the application to see if you can find anything additional. It's not always that you're going to find something, so I wouldn't fret too much on that. But take a look around and see what's there, if it makes sense. All right. So in conclusion, we spoke about what is functional testing versus non-functional testing. We spoke about functional testing strategies, the process for functional testing, and some best practices so you can be an amazing QA engineer. So that was our presentation on functional testing. I hope you enjoyed it. I hope you found it useful. I hope you found it informative. And even if you are not a QA engineer, I think this information is very helpful if you are in the tech field, if you work with QA engineers, whether you work more on the project management side, or you work with QA engineers as a developer or a security person. I think it's essential that you understand all the things that they do, so that way you can have a better understanding of what they're talking about and what they bring to the table when they're talking about like certain user requirements or certain acceptance criteria. I am a big believer of knowing, not necessarily doing what they do, but knowing how they do it. And that's why I always find myself learning more technologies, learning about HTML, learning about Docker, and everything like that, because it gives me, it makes me better equipped to work with the people that I work with. And then I can follow along and I can also make suggestions. All right. So on that note, if you have not done so yet, hit the subscribe button, hit the notification bell so you can know every time that we go live or drop a video, and hit the like button and share the video with a friend, family member, coworker, anyone who you believe will find this information useful, and we will go from there. So until next time, my friends, this is Tech Coach Ralph signing off.
If you enjoyed the fascinating information shared in this video and you want more, be sure to hit the subscribe button to Tech Coach Ralph to be notified for new videos.